Hi. Uh, Hi guys, this is Nikhil. Today we'll learn about load flow in ETAP. We all familiar with ETAP that we can do many electrical analysis in the ETAP software. So today we'll learn about load flow analysis in ETAP. This is one simple electrical network, or we call it as in a single line diagram, or shortcut SLD. Okay, here this diagram is built in an OLV page of an ETAP. You can see here these are many options you can see in the ETAP toolbar. These options are used for the different analysis in the ETAP. Okay, this is the edit mode. We can edit the parameters of the electrical devices, and this is the load flow symbol, this is the short circuit symbol, this is the arc, and many of the operations or analysis can be done in this ETAP. Today we will learn about load flow. Fine. In this load flow, what is the necessity of load flow? Before running this circuit, we will come to know what is the necessity of load flow and why do we need load flow in the electrical networks. Fine. In any electrical network, we want to know the load flow throughout the network, because if any fault occurs in the circuit, if you know how the load has been distributed and how the percentage of current and voltage has been distributed across each branches of a network, then you will easy to calculate the faulted current and the faulted voltage, and we can calculate the we can design the protective devices for particular places of the network. Here in load flow, this is what we do the load flow. From load flow, we normally in practical we distribute the power from substation to the consumer end, but here in ETAP we created taken as a grid as in a substation. Here we can see this square type is a grid. This is a grid. These are the grid quantities. We have to enter the grid quantities. Those are ratings are very important. Whatever the devices you take in the ETAP, these are the devices. Okay, these are the AC devices. These are the DC devices. Okay, these are the measuring instruments. Okay, whatever the instruments, whatever the devices you take, for every one of the instrument in the electrical network is much and more important is rating. We have to rate the devices for the particular applications. Here in rating page we are giving a voltage level of 33 kVA, and we have to give the capacity of that substation. So we are given that substation capacity is of around 2286.307 MVA, and X by R ratio, we know that X by R ratio is nothing but a short circuit ratio. Here the X by R ratio is a 14, and short circuit current is nothing but whenever the fault occurs in a network, this amount, the 40 kilo amps, will be occur in the grid or at the substation. This is what it means. And here the short circuit impedance, SC means short circuit impedance, for a base value of 100 MVA. These are the positive 0 and negative sequence values. Fine. Okay, this is the very important page, this rating and short circuit. In information we can enter the for identification we have to write the names, and one more important thing is, in information page we will get off, especially for generators and substations, we will get off a configuration slot. Here in this slot we have 4 types of operating modes. Okay, here first one is swing operating mode, voltage controlled, MVR controlled, and power factor controlled. Normally if you are using of in a single generator or in a single substation, the first one will act as a swing one. Why we call it as a swing one? Means swing is nothing but a reference one. We take a first one as a reference. If you connect a one more generator or a substation, then the second substation will act depending on the application. If you want to make a voltage control, if you want to make a MVA control, we can switch it and we can operate it. Now we are using only one grid, so we are taking as a swing. Fine. Okay, we come across this grid and this is the bus bar. Okay, for every in ETAP, no, it by default when two electrical devices are connected, then it by default it takes a one bus bar. Here we are drawn the bus bar. If we won't draw also, it takes by default bus bar. If I double click on it, here we can see that information page, it automatically takes the voltage value 33 is nothing but if you connect this bus to this source, what is the rating of this source will be there, that rated voltage will be accumulated in this bus. Okay, here the rating, I told rating is a very important page of every device in the electrical network, so we will go for the rating page. Here we have to one important thing is we have to select the standard as an IEC, because we in India we run in the IEC standards, whereas ANSI standards are followed by the American, and in India we follow it as an IEC. Is nothing but an international electrotechnical commission. Fine. Here we have to select in this type, what's the type is nothing but the bus which are connected, normally the bus will connected either sides will be of switch gears, so we choose the bus bar as a switch gear, and we have to rate that bus bar, because when the fault occurs or any overcurrent occurs, there may be a chances of breakdown of this buses, so we have to rate the buses as per the current level in the primary of this transformer or the voltage from source side. So I don't know this exact value, just I put off 4200. Here 4200, normally it won't be at primary side, because at higher voltage level there will be of very small amount of current. It's just for reference I am taking this, and the peak value depends. This can be calculated by the formula, that is to know the short circuit current we have to know the short circuit impedance and the short circuit MVA. We know that the short circuit MVA of source, and also we know the short circuit impedance also. If you make the calculations, we'll get around 40 to 50 kVA. 40 to 50 kA is nothing but 40 kilo amps. So I'm taking this, I just apply and click OK. Now here come this is the transformer. Here the two rings denotes that two winding transformer. Okay, if you take off three winding transformer, it indicates the three rings. Okay, here DYN11 is nothing but a delta star connected 11 is nothing but it is represents the phase phase and line voltage angle. This 11 is nothing but 30 degree minus 30 degree. Here 11 is nothing but 30 degrees. There will be a difference, phase angle difference between the line voltage and the phase voltage will be of 30 degree in the transformer. Okay, I double click on the transformer and I will rate it. Here I took off transformer. Fine. Here the bus primary side is connected as bus 1 and the secondary side is connected as a bus 2. Fine. And I told the rating page. In rating page we are step downing the 33 to 6.9. I will tell why the 6.9 has taken, and here we can see that why 6.6 is taken. I will explain you. Okay, this is a full load current. See, you can see that at primary side there will be a due to the highest voltage, the current level will be of low. This is current is nothing but an FLA. FLA is nothing but a full load amperes. Full load amperes as the primary side of the transformer is 437.4 amps and the secondary will be of 2000 amps. Fine. Okay, and the capacity of transformer, we know that the capacity of transformer normally we do in which units? MVA. Yes, exactly, not of megawatts. In MVA we measure the transformer capacity, so we give of 25 MVA as a maximum capacity for the transformer. And next, for the impedance page, here if you have a practical data or a practical values of an R and X and impedance values of the transformer, you can write it down. Otherwise, if you don't have a data, then by default here typical X and R by Z and X by R ratio, if you click this button, it will automatically calculate the as per rating, and it will note down the all these values. This is the special feature of the ETAP which was involved inside the ETAP. Okay, there is no need to go to the manufacturer side. We have to take the data and we have to put those values. Fine, if you don't have those values also, as per standards, the ETAP has been already inbuilt standards or the as per their standards, it will take the automatic data of this. And next, the tapping. Okay, this tapping will be useful when the voltage drop is high or low. Okay, then we will come across. Let it be now. We'll explain next. Fine. These are the two main parameters. One is rating and one is impedance. You should enter the impedance, otherwise it will show while running the load flow. It will show the error. Fine. This is the transformer, and same as it is here also. This is the transformer. This is also same rating. This is the C here. You can see here. I told that in transformers the secondary side is 6.9, but the bus is of 6.6. Why like that? Because in practically what happens now, normally the required rated voltage will be of 6.6, but if you if you step down the voltage level 33 to 6.6, then due to the distance and also some I square R losses, there will be of losses from transformer to some particular bus bar. So we will always ensure that the transformer step down or a step up level should be plus or minus 5% of the rated voltage level. So they are taken as a 6.9 voltage kilovolts, here 6.6 as a rated. Fine, I think you guys got. And we know that in Busbar the information rating is very important. It's taken already. Okay. Now this, one thing I forgot to tell in this Busbar. I told that in previous Busbar I given the continuous current ampere rating as some 4500 around. I don't know what is the primary side of the current will be there, so I put up like that. Here they have put in the 3000. Why they have put in here 3000 is, when you open this transformer, the secondary side, you can see the secondary side of a transformer, the amperes rating is 2092. Okay, it's around 2100 amps. So the bus bar should capable of withstand for the rating of the current. So they decided to rate as per standard of 3000 amps. We can take it as 2500 also, but they took off 3000. Fine. And this is a short circuit MVA. As we know, the current increases, the short circuit obvious the current increases. Next, here the circuit breaker. Fine, I think everyone know the circuit breaker. Circuit breaker is nothing but a device which is used for the protection of an electrical devices when abnormal conditions occurs in the system or any fault occurs in the system. Fine. Here this circuit breaker is used to protect these transformers and this whole network. Here the circuit breaker, I told, no, as usual, rating page, go to the rating page, IEC. In special feature of this ETAP is we have a inbuilt manufacturers and the ratings for the circuit breakers. If you click on this library, you can select the different manufacturers. ABB are there, Anson, GE, Siemens, Schneider, everything are there. As per requirements, you can choose and we can select them, so that the related data what you have selected will come on display here in the rating page. This is the rating page, rated kilovolts. See here the rated kilovolts is 7.2. As per standard it is a 6.6. The rated is of 7.2 because the 6.6 kilovolts circuit breaker is not available in this, so they took off 7.2. Next, the ampere rating is of obvious. We already discussed the 3000. and this is not much necessary. And very much important in the circuit breaker is making peak and breaking peak, or making current or a breaking current is nothing but whenever the fault occurs in a circuit, when the two contacts of the circuit breaker should open, is nothing but should break. When it breaks, that level will be of 40. The maximum, the maximum current or the maximum fault current should when it reaches to 40 kilo amps, then what happens, this breaking action will takes place in the circuit breaker and circuit breakers get open. But whereas come to this making peak, it is more than the breaking is only 40 kilo amps, but making is 100 kilo amps. Why? What is the difference? So you told that obvious the 40 kms it will break off, then if it goes for 100, why it won't breaks? Reason is, in making peak is nothing but whenever the two contacts get contact each other, then the first off cycle in AC, it reaches to a maximum due to the transient, the small period of transient, then the current will goes 2.5 times of the breaking current. Fine, this is the breaking current of 40. If you multiply the 2.5 into 40, you will get of 100. It's nothing but making current is always greater than breaking current. Fine, and this is the minimum delay given for the this circuit breaker. This is the 1 2 3 4 5 6. Okay, 6 parameters are very important in the circuit breaker when you are dealing with the circuit breakers. Next, this is the busbar, this transformer, this one. This is the lump load. Okay, we have a different types of load in the universe. Normally there are basically divided into 3 types: resistive load, inductive load, and a capacitive load. So we can't discriminate the loads on the depend on the usage, because every homes or every domestics or every industrials, they use all these three parameters as a combination. So we took off a lump load. In the lump load, we can differentiate, or we can power up the devices as per the required ratings. That will be in the nameplate. When you go to the nameplate of the lump load, here we can see that load type. Okay, load type are 2 types. One is of motor loading, another is of static loading. Motor loading is nothing but, as we know, that inductive load. Static load is nothing but a resistive load. Fine, when you scroll down this knob, we can rate the as per particular lightning, and also as a motor load. Okay, before going to these two, we have to give the specifications for the loading. These are the specifications. Here the rated kilovolts is of 6.6. obvious, we know that transformer is stepped down to 33 to 6.6, so this 6.6 will flow here. This 6.6 has a voltage rating, and the capacity of that load is of 14, and the megawatts will consume by this is 11.9. What is the difference between this 11 megawatt and MVA is, these are just differ by the one parameter called as a cos pi, that is a power factor. Depending on this power factor, these both will change. If the MVA is, the capacity is 14, if you want the megawatt also be in a 14, then this power factor should be around 100 to 100%. is nothing but out. So in practically we can't do the power factor is of 100%. So in industries, they will maintain the power factor near to 0.9 to 0.95. So we are taken of 0.85 is nothing but 85% is nothing but a 0.85 power factor. As at the power at this power factor and the MVA rating of 14, the megawatt is of 11.9 megawatts, and the ampere full load current or amperes delivered to this load is 1225 amps. Okay, fine. Think that's it in this lump load. Same as it is the circuit breakers and lump loads we are connected. Now I will show you how the load flow will we can learn. This is the edit option. In this we will edit all these parameters. This is the, see, I will put a cursor on this, it will show load flow. This load flow, if you click on this load flow, then you can change some parameters at the right side of the screen. Here the right side of the screen you can see, initially we have seen the parameters of the AC and DC devices, but here we are seeing that what are the operations can be done in this load flow. Okay, just I will inform you what all these and where we use all these in the circuit, when we will use also. This is, see, this is a run load flow. If you click this, the load flow will run and it will show the whatever the what is the total amount of load is distributed across the particular branches of the network and everything. And this is the auto run and off, is nothing but an if you run the load flow, after that if you want to change anything, then if you, after changing the parameters in the device, again you have to go to this run load flow and again you have to click. So due to that time wasting, so they have given that ETAP has provided one more option as an auto run on and off. It's nothing but while running only we can change the parameters and automatically it will run by the back end. Okay, this is the alert view. Okay, alert current calculations is nothing but is there any over current, is there any over voltage or under current or under voltage, it will indicate. See, this is also alert view, is nothing but just like this. This is related to current calculations and this is related to voltage, power and everything. This is report manager. In this report manager we can take the total scenario of the load flow. Fine, means when we run the load flow at the bus 1 and the bus 2, what is the power is distributed and what is the voltage level and what is the current level, we can see with documentation by this report manager. Fine, this load flow analyzer. Load flow analyzer is nothing but we can analyze the different different equipments in the load flow with separate reports. For example, if I want load consumed by the each transformers, only I want the transformers power consumption, then I can go in this option, I can select the particular device name transformer, and if I click on the OK, then I will get all the transformers power rating, power consumption rating I will get. This is how it works. And this is the load flow analyzer, just to analyze how it load flows. Display option. Display option is nothing but just to units and in which units you want to see, or what the, if the results are came, how the results you want in amps, you want in megawatts or MVA, like that. Fine. And this is the units enable and disable. If you click it is more units enable, then the beside the numbers you will get of units. I will show how it is. Fine, I will run the load flow now. See, here we can see the circuit. From this substation or from this grid we are supplying of 23 megawatts. Okay, from this 23 megawatts we are supplying the power to the two transformers as a 11.6 megawatts and 11.3 megawatts separately to the each individual transformers. Okay, and this bus bar is of 90%, is nothing but it indicates that when the bus bar has become red color, is it's just a alert, is nothing but this bus bar is in under voltage condition, it's not fully satisfied the rated voltage. And we can see that 99.96% of voltage level at this bus, and this is the power flow. We can see that here the 11.6 and here also the 11.6. Oh, here we can see that there are very less voltage drop or a power loss, we can say that. And this 11.6 will come here and it divides into two parts, because we have one load is here and one separate branch is here, and This load consumes of 10.7 megawatts, and the remaining will go to this circuit, same as it is in this side. This is also separates the power load flow to the load and also the sub branch. This is how the load flow will take place in the electrical network. Here we can observe these options. Just now I click this here. If I want to change these parameters, it goes again back and we have to run again the load flow. So to avoid this, the ETAP has provided us as a auto run on and off. Is nothing but we can run the load flow in between this load flow. We can edit the parameters of the devices of any particular system. Okay, see, it's running. This is how it works. And if you go to this alert view, see, it's showing that bell symbol. If you click on that, it will ensure that whatever the faults or whatever the dangerous part has been affected in the electrical network. If I click here, you can see that the bus 1 are under voltage. This is the bus 1, this is it under voltage. It's nothing but how you can say that under voltage or over voltage. Here they given that rated is of 33 kVA, but the operating is of 29.7 kV, sorry. So from this we can say that the operating is lesser than this rated one, so it is in under voltage. So we have to improve that voltage level. Okay, and next, this is the report manager. Here in this report manager, we can take the reports of overall summary of this load flow. I will show you how it is. Okay, when you click on this, you will get of complete input, result and summary. You can take the complete report, means you have to click on the complete viewer. If you want to view and if you want to view and just close off, then you can select the viewer. Or if you want a PDF files, you can select the PDF files or MS Word, like that. There are many options. I selected as a viewer, and I will select the complete network. I want to view the load flow, and I will click off OK. Let's see what are the results, how they shows. See here in heading, which shows that load flow analysis. Fine, this is ETAP 19 version load flow analysis we are doing with a loading characterized of peak load and a generator of minimum power voltage generation. We'll discuss about those things afterwards. Here see, number of buses, swing bus is 1, because we are connected only single bus at the source side, and the loads are of 6, total the 7 are there. 7 buses, total number of buses are 7, and the number of branches 4. FXMA is nothing but transformers of 4. Next, and one more thing here, this load flow runs on the basis of an adaptive Newton-Raphson method. Behind this, whatever we click on the options on the screen, it works on this Newton-Raphson method. Behind this behind this screen, it runs in this principle, and the number of iterations will be of maximum 99 iteration, and the precision is very high, it's of 0.0001, and we know that the frequency is of 50 Hertz as per Indian standards. Now we'll go for next page. Click here. These are the parameters, impedance and reactance values we can see here. And the bus data is nothing but what is the input of the bus 1 and what is the input of a bus 2, and bus input data, and the magnitudes are in percentage, and the voltage angles, and the power delivering to the respective buses to the load side. These buses are connected to the load side, so the power megawatt and MVA are showing to the particular buses, and the 1 and 2 are not showing because there is no load connected to these buses. And this is a generating bus, is nothing but bus 1 lot generation side or in a grid side. And this is the two winding transformer input data. This is we all can see the ratings, impedance values, tapping values, phase shifts, and everything we can see here. Branch connections, from which bus to which bus, what is connected, and what is the resistance value, what is the reactance value, what is the impedance value between the bus 1 and 2, what is the between the bus 1 and 2, what is connected. It's a two winding transformer, T1 is connected, so there the impedance, current, resistance value is this much, impedance value, inductance value, impedance value is this much. And this is the load flow report. This is the full load flow report. Here we can see that what is the voltage level at the beginning, and also we can see that end also, and these are the angles, magnitudes, and power flow in the bus respective buses, and the power factor, operating power factor at the buses. Bus loading summary report means the buses which are connected for the some respective buses, those buses will show the what is the total load connected to the respective buses, and what is the power factor and operating on those buses, and we can see all those things here. And these are very important. Here the branch losses summary report is nothing but when you run the load flow, we can see the what is the percentage of losses at different stages of the network. Here from the transformer and from the transformer 1 and 2, there is 5.73% of voltage drop. Here we can see that from to bus flow. This is alert view. Here we can see all of them are 100%, so there is no dangerous or any fault. That's it. This is how this remote report manager will work. And you know that this display options I have been explained. In this display option, we can change the output of the power from the particular network or from the particular branch as per our requirement. Now it is in megawatts. Why we are selected here in megawatts? So yes, it's showing in a megawatts. If you want to see that output in an MVA and amps with respect to power factor, you have to select this. And if you want to show the units, fine. If you don't want to show the units, you can unclick it. I want the units, so I will click it. Okay, here we can see that MVA, current reading, and also operating power factor. Okay, you can see now. This is how this display option will work. And here below units, I have been already explained that this units, if you enable it, the numbers beside the units which we have been provided will be of shown. If it is disabled, then the units will be disabled. So it should be always enabled, so that we will come to know what are the numbers and what they will deals with. Next, MVA and amperes or megawatts, in which type you want. It has a direct here. This is the percentage voltage, is nothing but click to voltage. We can see the what is the percentage of voltage at the buses, or you can see in the volts, kilovolts, or you can see in the volts, normal volts. This is how this operates. Voltage. This is terminal load terminal voltage, is nothing but what is the terminal voltages at the load sides. We can see that here. See here, this is the bus voltage. It will indicate. This indicates the load terminal voltages. And this line cable or any, if you provided any lines or any underground cables. If you want to see the power losses or voltage losses at respective cables, you can select this, then you will come to know. But here we didn't use any cables or underground cable or transmission lines, so it not necessary. Okay, I think you guys haven't got this all. This is how the load flow will run, and thanks a lot.